Hello and welcome back. In this video, our goal is to find the local max and mins for this function using the first derivative test. And that's going to require us to draw a sign chart or a number line with the sign of our derivative and then look at where it's changing from increasing to decreasing by looking at the change in signs. So the first thing we want to do, of course, is find our derivative for this function, which is pretty simple, being a polynomial. F prime of x is just 6x squared plus 6 times x minus 12, which we know we can factor nicely as 6 times x squared plus x minus 2. One more further attempt at factoring. We have 6 times x plus 2 and x minus 1. Now, since this derivative is polynomial, we don't have any places where it's undefined, but we do have two critical numbers from setting it equal to 0. And by inspection, we see that both x equals -2 and x equals +1 are critical since they make our derivative equal to 0. The next thing we need to do is draw a number line. So we're going to draw a number line for our derivative. And once again, we're going to plot our two critical numbers, -2 and +1. And again, our derivative is 0 at those two locations. All right, so next thing to do is now pick test values on different sides of these critical numbers to see if we have a positive or negative derivative. If you take a value greater than 1, such as 2, it should be pretty obvious to us that f prime of 2 is going to be greater than 0. So we have a positive derivative over here. A nice number between -2 and 1 would be 0. And you'll notice that f prime of 0 is going to be less than 0 because 0 gives us -12 for our derivative. So we're going to have a negative derivative at 0 and every point up to the critical numbers. And then finally, we can calculate our derivative at -3, which is left of -2. And -3 inside of our derivative is going to give us a positive number because we're multiplying two negatives. So on that side of the number line, we've got positives. So we can also talk about increasing and decreasing. We are increasing from -infinity to -2 because of the fact that we have a positive derivative. So we'll draw little up arrows for that. Between -2 and 1, we are decreasing. And then from 1 to infinity, we are increasing again. But the goal of this problem was to actually find the extrema. It was not to find the increasing and decreasing intervals. So because our first derivative changes from positive to -2, that's going to be a relative max. And then later on, we'll notice that we have a min at 1. So we're going to write this up accurately and thoroughly. We're going to say that since f prime of x changes from positive to negative at x equals -2, f of -2, which we will calculate in a second here, is going to be a relative maximum. And now we need to go back to the original function to get our value. And that value, when you go back, will be the function value at -2. And that works out to be 2 times -2 cubed plus 3 times -2 squared minus 12 times -2. And that works out to be exactly 20. So 20 is the value of the relative maximum at the point -2. Now we have one more answer to find, and that is what happens at 1. And so for that one, we know that since f prime of x changes from negative to positive at x equals 1, f of 1, which if we go back to original function, is going to be -7, is a relative minimum. So we have two relative extrema for this cubic polynomial. And again, the process starts with us taking the derivative, finding the critical numbers, plotting the critical numbers on a number line, testing out values in between the critical numbers to determine if we have a positive or negative derivative, and then looking at sign changes in our derivative that happen at the critical numbers. Again, if our critical number changes sign, then we know we've got either relative max or min depending on which way it changes.